afternoon, friends. Welcome to fourth day session. And before getting into the session, I would like to have a formal chat with Busi Anil sir. Kindly concentrate on what we are talking, so that how can you grab some information when teachers are in a seminar when the panelists they are talking. Uh, Busi Anil sir,
Yes,
what
sir.
is the date today?
Today's date is 23rd, sir.
What was yesterday?
22nd.
What is the month?
This is July
July means 6 or 7.
7.
7.
7. What is the relation between 27, 22 and 7?
22
Is
and
there is
7 is the pi.
Oh, very nice. Great. Pi is nothing but 22 by 7.
Yes.
What a relevance.
Uh,
And what is the fraction you will get when you divide it?
Fraction 3.14 and odd.
Oh, yeah. Very good, very good. So 3.114. How can you remember 3.14?
March
If you
14th.
remember, no,
March
just
14th.
simple. I will tell you one thing. If you remember a sentence, Mom, I love you, you can
Hmm.
remember this. Mom is 3.
Acha, 1 4.
I is 1. Love is
Okay.
4. So 143 students, they will generally remember that.
Yes,
So
yes,
let
yes,
us
yes.
say, Mom, I love you. Then you can remember 3.14,
Yes,
right?
yes, 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 yes.
And one wonderful information is, what is third month?
March.
March. March 14th is the birthday of Albert Einstein.
Oh,
So 3.14 is the birthday of Albert Einstein. So
oh.
information can be drawn from nonsense things and we can convert into intellectual things.
Yeah, yeah.
Okay. Hope the students also enjoyed this discussion.
Actually,
And
I just want to add one more point, sir.
yes, sir. Welcome.
Because you have raised this point, and I remember that. I remember one thing that Pi. There is a day called Pi Day. That Pi Day is nothing but March 14th. So
This
Pi
is
Day,
called as Pi Approximation Day. Pi
yeah, Pi
Approximation Day.
approximation day.
It is
But people
celebrated on March 14th.
14th, yeah, that's how also we can
Pi
just
Approximation
relate
Day.
both. Yeah.
Even 22/7. Yesterday was also 22/2. We can celebrate that also.
Yes, yes,
And
yes.
Albert and birthday. So this is the
Okay,
correlation.
this Albert Einstein's
Okay. I
birthday is
welcome
something
Shan.
that is.
Busi Anil sir.
Yes, sir. Yes, sir.
Yes, sir. Okay. Please continue with the session.
Okay, okay,
Busi
okay.
Anil,
Right,
take
right.
over.
Right, sir. Right, sir. Thank you.
Right.
Thank you so much, sir. Okay. Now
Thanks.
we have enough of students on the list, to carry on forward this topic. So let me share first ChemDraw with you. So this is what. See, quickly, I just want to finish it off the remaining two examples that I just could not cover yesterday. That is structure 5 and structure 6. Once I finish that, probably, I'll be finishing a different, structures of having varied connectivities and all of that. So I'll just quickly go through structure 5 and structure 6. We have already finished the structure 1, structure 2, and structure 3. Let me show you. Uh, these are the structures. Yesterday we just finished. This is the structure 1. How to draw the structure 1, and how can we grab different pieces of information, and how can we attribute numbering, name, and color, okay, to the structures. All these aspects of it we have covered yesterday. And second structure also we have drawn. This is cyclic in nature. And when it comes to structure 3, this is a pressure projection kind of a structure that also we have seen. Now let us move on to uh, structure 4, and this is a perspective kind of a model of a structure, and these kind of structures also you can draw. And let us see this Newman kind of a projection, and then after that we will move on to this stereochemistry attributions to the structures. Okay, let me just quickly copy the structure, and let me open a new sheet, and I'll try to paste it over here so that we don't need to move every time, back and forth. This is the structure 5. Okay, how do we draw that? How do we draw this structure? Actually, last yesterday I just wanted to skip these two structures, but I have realized after that this is something, Newman projection formula. How do we draw that? If you probably know, it will definitely benefit you better. That is the reason why I just want to finish the structure. And the last one is very simple one, that is not a problem at all. So how do we draw the structure? That is very, very important. See, this is nothing but an ethane molecule, but not in a normal way it is being presented. It is being presented in the form of Newman projection formula. So how do we do that? It's very simple. First of all, all are single bonds only. There are six single bonds are there. One, two, three, four, five, six. So let me just put the single bonds first. Okay. So this is okay. How do we do that? It's very simple. Okay. First you draw one single bond, vertical single bond. Then after that, you just put your cursor at one of the end of the single bond, and you try to just click. Then you will get one single bond, and you try to click, and you will get another single bond. So we have written literally CH3. CH3. Okay. So let me, if you want to maximize this structure, it's very simple. Try to use these marquee tool or lasso tool. Just click any one of that and automatically it will get selected. Then after that, you try to increase the size if you want to. Okay. To make it the structure more clear. Okay. This is how you can increase. Now, the second step is what? First step is simply just use a single solid bond and you try to generate CH3 uh, CH3 part of that ethane. Then after that, simply you don't need to. You have to draw another CH3. If you want to draw, you can draw simply just like that. Otherwise, if you want to make a copy of it, it's very simple. Try to select this structure and try to copy, right click and use the option of copy and just deselect this and try to use any in any other place of this platform. Try to right click and you will be given these options under which you try to click the paste button. Then automatically you will get this uh, another copy of CH3 moiety. Okay, that is how you can do it. There is another way also. There is another way, simple way. Shortcut formula is what? If you want to make a copy of any structure, it's very simple. You try to select that structure. You try to select that structure. Previously, what I've taught to you is a manually copying and pasting the way we do it in Word, Excel, and PowerPoint. Here, how do we do that? In a simple way, because while we are going to draw too many reactions and too many structures on ChemDraw, every time we don't need to use right click, copy, and again right click and paste. Simply uh, press shift button or control button. Press control button on your keyboard and try to just drag. Try to drag. Then automatically you will get another copy. How do I do that? It's very simple. Try to select the structure. Try to select the structure. This is a shortcut formula for making copies. For making copies of structures and reactions. Reactions also I'll be going to teach you today. How do we do the copies? Okay, number of copies you can do it. Number of copies you can do it. How do we do that? Simply select the structure and press Control button on your keyboard and try to drag. Try to drag. Then automatically you'll get a copy. You can make n number of copies like that. N number of copies like that. Okay, that is not a problem. Simply by dragging, by pressing Control button on your keyboard, you can just make n number of copies. Okay, that is not a big problem at all. So I would suggest you to use always this Control button on your keyboard to make a different number, because you can make, when you are going to write reactions, that is going to be very helpful. Okay, let me just remove fixed angles and fixed bonds. Now what I'm going to do is, since this is an ethane molecule, okay, let me position these two structures in a proper manner. Now what I'm going to do is I'm going to draw a carbon-carbon bond. Okay, this is how I'm going to write carbon-carbon bond. So now I have actually made a CH3CH3, that means ethane molecule. Now what I'm going to do is I need a circle. Just clearly look at this molecule carefully. I need a circle. From where do I borrow the circle? It's very simple. You try to go to the main toolbar. As I told you, maximum number of the tools that are available in main toolbar only. If you try to make utilize of main toolbar properly, I don't think, very few times, you need to go to other toolbars. Otherwise, you don't need to go to any other toolbar. Simply make use of it. Here you can see it's orbitals. Orbitals tab or here in main toolbar. Just try to click. Okay, try to click that. And there are plenty of other shapes are also present in it, but we want this kind of a circle. So click that and try to just put our Okay, try to just one of the CH3 moiety. Try to put one of the CH3 moiety. Okay, that's how you have to paste it. Now, what you need to do, this is something very important. I want you to concentrate on it. How do you do that? Simply select the other CH3. Simply select the other CH3 moiety and try to. This is something very important. Try to rotate that. Try to rotate this moiety exactly 180 degrees. How do we do that? How do we do that? It's very simple, because by looking at this, okay, by looking at this molecule, you can visualize that this is the circle that we have, and this hydrogen, this CH hydrogen, this one and this one, these three bonds are there on the positions. But if we drag like this, now I'm going to drag this, drag this molecule like this, then what is going to happen? It is going to be an eclipsed Newman projection formula. We don't want eclipsed. We want a staggered. We want a staggered. Just look at it here. This is a staggered one. When we want a staggered one, what do we do? It's very simple. You need to flip. You need to flip this particular CH3 moiety. How do we do that? Simply by selecting it, you can go to object. You can go to object. Okay. You can select rotate. You can select rotate. Under this rotation, just you type 180 and degrees clockwise being selected. If you flip that, then automatically it gets flipped to 180 degrees. How do we do that? Let me show you again. Simply select the moiety which you want to rotate it or flip. Simply select that and go to object, because this is an object, and try to use the option of rotate. Try to use the option of rotate, and you try to type whatever the angle that you want to rotate, clockwise or anti-clockwise, and select that option. Then according to that, you do it. This is how you have done it. So it's very simple. Now it got rotated. If you try to drag this moiety onto it, this is how it comes. But just have a look at this. Both the structures, are they same? No, they are not same, because the way all you are unable to see the front part is what, and back back part is what. Both are trying to be there on the back side of the circle. It should not be like that. So what do we do that? Before dragging this moiety onto this, what we need to do is simply right click it, right click, and you just use the option of bring to front. Use the option of bring to front. What do you need to do to make it come front side? Okay. Let me select this moiety. Let me select this moiety and right click that. Then use the option of bring to front. Bring to front. Once you click, and after that, if you drag it, then automatically it's going to be perfect. It's going to be perfect. Just look at this. Now almost we got the same shape. Now what we need to do, simply you put hydrogens. You know how to put hydrogens, letters, groups, and everything using text tool. Text tool. Click the text tool from main toolbar and try to just add hydrogen. Okay. Here one more shortcut formula I would like to tell you. So manually instead of adding like click hydrogen, typing hydrogen and click type hydrogen, instead of that, once you just simply you can do one thing. Simply go to where you want to add hydrogen, double click, automatically hydrogen appears. You don't need to just type hydrogen. Whatever the letter that you type previously, that will be automatically saved. So what happens once you go and try to add by simply clicking twice, so automatically that previously added atom, it appears. This is one of the shortcut formulas, so that you don't need to type manually. If there is one group, it is there 5 times or 6 times in your molecule. One time typing that particular group, then after that simply putting your cursor on the places where you want to type that group again, double click with your mouse, then automatically it appears. That's how you can add. So you know that once we get the molecule, you can get the names, and you can change the color, and you can get chemical analysis data, you can get chemical properties data, and you can move the molecule from one side to another side, and all these things you can do. Yesterday only I just told you all of that. Okay, if you want me to just show a little bit about this. Sorry. Okay, so this is the molecule. If you want to get a name of this molecule, it's very simple. Select that particular molecule and try to click structure to name. Then automatically you will get an ethane name. Okay, if you want to change the bond colors or atom colors, you can use this general toolbar color option, and according to that you can change it. Just like that, If you want to say, for example, move from one place to another place, I told you, okay, I told you, you can change it, and you can change, increase or decrease the size of it, by simply using corners, by increasing and decreasing, and you can do this one. It's going to be cool. Then after that, if you want to add some chemical analysis data and chemical properties data, you can use the structure menu on the top, structure menu on the top, and sorry, this is view menu on top, and you can use chemical analysis data of this particular ethane. You can see the formula is ethane, and if you want to paste it, you can paste it automatically. It appears over here. Okay. Then after that, if you want to add chemical properties, also go to view and the chemical properties data. Okay, that also you can, if you want to, just you can add it. That's not a problem. The only thing is, just you have to select. You have to select. You have to use chemical properties data. Okay, so this is chemical properties data. If you paste it, then automatically it comes over here. Okay, it comes over here. Just like that, if you want to have a proton NMR spectra and carbon 13 NMR spectra, simply this structure being selected, you go to structure and use predict proton NMR shift and predict carbon 13 NMR shift. That's how you can manage it. Okay, so
నేను
the
క్లాస్ గిల్లు కూడా సిస్టమ్
excuse
కొని కొని మా
excuse
అయ్య అయితే క్లాస్ వింటానంటే డైరెక్ట్ కొని
yeah.
Hello, Butsi.
Yes, sir. Okay. Now, okay, let me move on to the another example. Let me move on to the another example. Okay, the last example. This is the last example. This is the last example. Let me just copy this and let me use another page. Let me paste that. Okay, so let me put it in the proper positions. So this is a molecule structure involving stereochemistry. So this is another kind of an example out of all the six examples that I chose. Everyone is a little bit different from one structure to another structure. So that whatever the tools that I'm using in each structure, just please kindly make a note of it. These structure, the ChemDraw is nothing but a collection of all these structures. So how do we do that? It's very simple. What is the basic difference from this structure to another structure? Just try to concentrate on it. Single bonds, these single bonds and this double bond and the single bond and OH and O, we can draw it very easily because we have already practiced with other structures in previous examples. Okay. So when it comes to here, even the name also we can generate it. That is not a problem. So here, this so-called wedged bond, thick wedged bond, this is something that we have not tried till now. Okay. And another stereochemical representation over here. Stereochemical representation over here. This is also something we have not tried till now. So these two are the new features of this particular molecular structure that we are going to see. So how do we start that? It's very simple. Let us start with the single bond. Okay, how to draw a single bond? Just simply go to the main toolbar and click the single bond and you draw that. Okay, then after that, another single bond. Okay, simple. Then after that, another single bond. Okay, then after that, another single bond. Okay, this is how. So what we need to do after that, we need to add this double bond. So to get a double bond, simply go to this particular place and where you will see all different kinds of double bonds. Simply come to a place where you want to insert the double bond. So insert the double bond. Okay. So then after that, what you need to do is simply add these two letters. Okay, these two letters. In fact, if you want to add, this bond also, you can add it later. That's not a problem. So let me add this oxygen and OH. Okay, how do we do that? Letters and groups. Simply use the text tool and click and try to type O. Then it is over. Then after that, go to another place where you want to just put OH. Okay, type. That's over. Okay. Then after that, what you need to do is simply you have to add here a wedged bond. Directly, if you try to, if you want to add it, you can add it like this. Otherwise, there is another option also. Try to put single bond initially. If you want to convert that into a thick wedge bond or hashed bond, any bond that you want to, just simply you can do it by simply selecting the thick wedged bond from a main toolbar. Select that and just simply select this bond. Automatically, it turns out to be thick wedge bond. Okay, what you need to add here, NH2. You know that how to add letters and groups, again, same way, text tool and put it over here and NH2. Okay, now, sorry. NH2. Okay, so this is how you can add the thick wedge bond and the letters and single bonds and double bonds. So now what you need to do is, it's very simple. This is um, if you want to turn a little bit, okay, so you can place it like this. So if you want to increase this molecule, the size of it, and you can increase it or you can decrease it, whatever that you want to do, you can do it. Now we have done all of it except this stereochemical representation or symbol. How do we do that? It's very simple. Just try to select the molecule for which the stereochemical symbols are attributed. Simply go to the you know sorry, object, object, just go to show stereochemistry. Okay, where you need to go? You need to go to object menu bar and simply click show stereochemistry. The moment you click that, then automatically you'll get a yes. Here you can see this. Okay, if you want to make it bold, you can make it bold. Okay, if you want to increase the size also, you can increase. Here, the this general toolbar will help you to just modify the letters and symbols and everything. If you want to increase the size, you can increase the size to yes. Okay, that's how you can do it. This is a molecule. Now, just like every other molecule, if you want to attribute a name, simply by selecting that structure to name, click that, then automatically you'll get a name of it. You'll get a name of it. Just look at it, both the names are same. Okay. Then after that, if you want to add numbers to it also, I told you yesterday, adding name, increasing size, moving an object, okay, from one place to another place, then adding numbers, okay, adding numbers also you can do it. Just go to objects, okay, show numbers, then automatically you'll get the numbers for each and everything. Okay, that's also you can do it. Otherwise, if you want to attribute different kinds of colors, for example, this is a thick wedged bond. This is something that you want to give a different color. Select that particular bond. Select that particular bond with this marquee or lasso tools. Then go to the color option in general toolbar, top right corner, and go and try to give another color to that, so that it looks a little different. This looks a little different. That's how you can attribute the colors. Again, just like that in previous examples, select the molecule and go to view and show analysis window and paste it. You'll get it. Again, you just go to view and chemical properties window and paste it. Okay, then automatically you'll get all the properties below that. Okay. This is previous. Okay, this is how you can do it. If you want to just get a, if you want to get a proton NMR, okay, carbon 13 NMR, you can go to this predict proton NMR spectra and predict carbon 13 NMR spectra. Then automatically you will get those spectra. If you want to get proton NMR for this particular molecule, you can get it like this. Okay, which I have already shown you, so that I'm not going really deep into it. This is how we can draw different kinds of structures, and we can attribute different kinds of features of the structures. So I have shown you 6 different kinds of examples. In the process of it, we have learned different things, different features are the tools and how do we use to draw chemical structures. We have seen that. Now this examples part is over. Now let me recapitulate. Okay, what actually we have finished for the last 3 days. This is the 4th day. So what are the 3 days? First day, I try to just tell you that there is a software and which we can download it. We have a trial version that is available. That basically I have focused on that, and I try to quickly go through all the menu bars that are present in the ChemDraw. That was the first day's class essence of it. And when it comes to second day, what mainly I have focused on is toolbars. Okay, toolbars. The toolbars means how many different kinds of toolbars are there. I just told you 29 toolbars are there. Toolbars are nothing but baskets of tools. So altogether we have 200 to 300 different kinds of tools. First, I have given you the tools to your hand. First, I have given you tools to your hand in the second class. When it comes to the third class, what I have shown you, that means yesterday's class, I just started to give you examples, objects, what we can create with the help of those tools. What kind of an objects that we can create. So I have taken 6 different kinds of examples, 6 different kinds of examples. So all these examples can be created with the help of the tool sets that I have introduced in the second class. So in fact, not only created, you can do modifications also. You can do, if you want to erase some bonds, some atoms, there is an erase tool on the main toolbar, with which you can, if you want to do it, you can do it. So basically how to create and how to modify, that I have tried to show you in the last class and today's class with the first 2 examples. Then another question that should pop up in your mind, what is that? So manually, if we are trying to do like this, it takes a lot of amount of time. it takes a lot of amount of time. For example, we will be going to have, for example, BSc students might not be facing, experiencing, like big reactions, only small reactions, maximum 4 steps, 5 steps. I don't think, more than 5 steps in mechanisms, you don't find any other reaction. But when it comes to MSc, you will have natural product synthesis. Okay. And if you go to PhD also, you'll be going to go do a big reactions, which involves almost like a 80 steps, 100 steps reactions are also there in the mechanism. Just imagine typing manually each bond, single bond, double bonds, and adding letters and groups, just to write one single reaction with mechanisms, it's going to take a lot of amount of time. Is it really something, that is a sort, that is something sorted after? No, no, it's not like that. So we need some shortcut tools. So if you excel in these shortcut tools, probably you are going to draw even 80 steps of reactions also in a matter of 5 minutes. In a matter of 5 minutes. Even in, for example, you can imagine if 5 step reactions or 2 step reactions, hardly it takes 20 seconds or 10 seconds. The only thing is, I'm going to give you now all the shortcuts that are available, because this is something very important. Whether you know it or not, those people who are using Photoshop, those people who are using editing softwares, high-end editing softwares, they don't do it manually. After a lot of amount of practice, they'll reach to a stage, they will keep all the shortcut formulas in their mind, and with those shortcut formulas, they will do very quickly. If they are trying to do manually, and things will not be done quite quickly. So that is also very important. Not only creating and modifying chemical structures and mechanisms, but you need to do them in a short span of time, big reactions with mechanisms and structures. That's what you need to. Okay. So today I am just going to just show you the shortcut, ways of getting the structures and the modifications and all of that. So let me go quickly and just tell you all of that. So let me take a new document. This is a new document. Okay. Now, let me show you. Let me start with the first thing. What is that? For example, there is a small molecule like acetone or acetic acid. These things you can draw it manually. That is not a problem. But if you have a bigger molecules, for example, very big enough that, is it really necessary for us to every time draw manually? No. Here one option is there here, name to structure. Name to structure. Okay, just click that option. Automatically a pop-up window will appear. Any name that you type it here, simply it will bring that particular molecule onto our platform. Let me show you a few examples. Like for example, I want to just let me start with a simple example. Acetic acid. Okay. Instead of drawing, if you know the name, simply type that and click. Automatically you will get acetic acid molecule. Okay. So quicker way of getting molecular structures. See what happens sometimes, we don't need to draw the, basic molecule. See, try to borrow the basic molecules and you try to copy. I'll show you that today, that you can copy that structure and you can do little modifications. What is the chemical reaction? Chemical reaction means, the whole molecule will not be disintegrated, and all again new bonds will not be formed. Chemical reaction means, very few atoms or very few bonds in a bigger molecule, they'll get dissociated, or they will move from one place to another place. So while you are writing chemical reactions also, simply just first borrow a bigger molecule, which is the initial reactant. Then after that, you try to do, it's simply copy the same molecule, and I try to do the small modification that you need to do with the help of main toolbar. Okay, that is a quicker way of doing the chemical reactions and drawing chemical structures. So what you need to do is simply use this option of name to structure. Simply click that and a pop-up window will come. For example, acetic acid, you can draw it. But when it comes to, for example, EDTA, simply type EDTA. You know that EDTA is a bigger molecule. So how much time it takes? Definitely to draw this molecule, you will get 1 minute. 1 minute. In 1 second, you can get it. 1 second, you can get the structure. How do we get that? It's very simple. Use this name to structure and you type EDTA, then you click that. Then automatically you'll get this. So let me just show you another bigger molecules. Not only, see, EDTA is the most complex molecule. No, there are some other molecules are also there. For example, let me show you vitamin A, vitamin E. Okay, vitamin E. If anybody asks you to draw this molecule, okay, it takes a little bit of time. Why to waste that time? Simply use this feature of name to structure. So automatically you'll get this vitamin E. So how much? It's a fraction of seconds you'll get it. So this is very wonderful feature. That is one feature. Any name you put it, then automatically you will get the structure of it. Okay, if you want me to just type another, vitamins, mostly biology people, they'll use okay, vitamin B1. So this is also a bigger molecule. okay, that you can get it easily, borrow it easily from the databases by simply using the feature of this structure toolbar. In the structure toolbar, you can just get that. That is one of the shortcut formula that I wanted to just tell you. So somebody is asking yesterday also, sir, while we are going to write the reactions, how do we write that? Till now, what I have discussed with you only is the structures drawing. Structures drawing, even today also, just now I have told you that how to borrow the structures from the databases. Now, how do we use these structures to draw? How do we use these structures to draw chemical reactions? It's very simple. I've shown you, for example, let me just borrow, ascorbic acid. Okay, this is one of the molecule. Let me just get it. This is an ascorbic molecule, ascorbic acid. Okay, I want to write reactions based on that. How do we do that? Simply make it selected. Okay, for example, this name, if you want to delete it, you can delete it. So this is a molecule. Okay, I told you just today only, if you want to make a copy of, if you want to make a copy of a molecule, what you need to do, it's simply manually. If you want to do it, you can do it. Simply right click and copy. Then after that, again deselect this molecule and right click on any other place of this platform, and then after that again paste it. This is a manual way of doing it. Okay, it takes a little bit of time. Simply select it. Shortcut formula, what did I tell you? Just press Control on your keyboard and simply drag. Try to drag. Then automatically you will get plenty of these, molecules, copies of it. You know that, okay? What is a chemical reaction? Chemical reaction is not a complete modification of the molecule. Simply some places gets modified. That's it. So getting different copies of this, for example, 3 to 4 steps are there. 3 to 4 times you can copy this molecule. Then after that you can put arrow marks. Then according to that you can do some changes. Then your reactions will be over. So how do we do that? I told you, just simply select Control. Then automatically you simply drag. Okay, you put it like this. Then after that you put an arrow. To put an arrow, what you need to do? Go to main toolbar and select that arrow. Then you try to drag that arrow. Okay, this is how you can do it. Okay, then if you want to put anything on top of it, like reagents and reaction conditions, what you need to do, use the text tool. Simply go and type it. Any reagent that you want, you type it. For example, platinum. Okay, hydrogen. Okay, that's how you can do it. Okay, otherwise just a temperature, if you want to, sorry, for example, let me write it. Hydrogen in the presence of platinum. Okay, so here you can see this is not in a proper formula manner, because here you can see this is not selected. On the general toolbar, CH2 is not selected. If you select this and you then after that you press this CH2, then automatically it turns out to be in a formula manner. So that is something that you need to learn. Then after that you can just type temperatures, for example. Okay, like 300 degrees centigrade temperature. Okay, if you want to put a superscript, you can put superscript. Okay, by selecting this superscript, then after that 300 degrees centigrade. So that's how you can add it. If you want to change these letters, font, bold, everything, you can use general toolbar. General toolbar will help you to change different kinds of things, as far as this atoms and bonds and groups are concerned. You can just modify in any other manner that you want. Okay, this is how you can add it. So is this the only way to do chemical reactions, by simply taking a fundamental molecule, then after that making copies of it and putting arrows in between that and try to put the reagents on top of it, and below, another, temperatures and pressures, that there is another simple way also is present. That will also I'll teach to you. So what is that? Okay, let me just show you. Okay, so this is a molecule. Simply, you just, sorry, select the molecule. So here you don't need to just making a copy. Then after that, putting an arrow mark and all these things. Even these two things are also taking a little bit of time, right? You don't need to do anything. Select the molecule. Press Control on your keyboard. Use the arrows that are present in it. Up, down, left, and right arrows are present on your keyboard, right? Try to use that. How do we do that? Simply select the molecule, press Control, then after that use the arrows. Right arrow, if I use it, this is how it will get automatically. I am not even using the arrow tools of the main toolbar. I'm not going into there at all. Okay, simply using just a keyboard. After selecting the molecule, press the Control, then use the right arrow. If you want to use. Otherwise, if you want to use up arrow also, you can use up arrow. Okay, for example, okay, if you want to use up arrow, then automatically reaction moves a little bit. Okay, so let me just delete this. Let me show you. So down arrow, this is down arrow. If you want to write the reactions in a vertical manner, you can move down. Okay, so this is let me show you. Okay, so if you want to just write if you want to write the reactions in a upward manner, simply select that and press control and up arrow, then automatically you'll get it like this. Okay, it's all about the space, that's the reason why. Okay, so let me decrease the size of it. Okay, so let me decrease the size of it, and if you want to select if you want to write reactions on the so let me select this molecule and right arrow also. If you type it, then automatically this is out as many number of times as possible. Again, down arrow. Okay, and if you want to go to up, that's also you can do it. Up. That's how you can write quickly the reactions. Then after that, simply by doing modifications, you will be in a position to just do that. Some people were asking yesterday that how do we do the reactions? If you know how to draw a particular molecule initially, then after that, drawing reaction is not a big problem, because you can use this one single control button. You can make copies of it manually. You can add arrow marks. Otherwise, simply use the up, down, and right and left arrows that are present on the keyboard, and you can generate within fraction of seconds almost 10 or 100 steps also. Simply keep on pressing it and you will get 100 steps within just 20 seconds. That is not a problem. Okay, so this is something that I wanted to tell you. Reactions is not a big problem at all. Okay, so then after that, the most important thing that I would like to move on to today, because I have promised you yesterday that today I'm going to concentrate on the shortcut formulas. The main shortcut formulas that you'll get it to draw the structures quite easily is from go to file menu and go to open samples. Go to file menu, open samples. There you will find enhanced hotkeys cheat sheet. So cheat sheet, this is something very important. Enhanced hotkeys cheat sheet. Just click that, then you will get a sheet of all shortcuts. Sheet of all shortcuts. This is something that you need to spend a little time about it. So if you excel in it, okay, as I told you, by practice you can excel on this sheet. That means what? You will remember all the shortcut formulas by practicing it. Once you remember this single sheet, I can tell you, I think no reaction will take, even the most difficult reactions like 80 steps reaction also, it won't take more than 5 minutes. Okay, every other reaction will be in terms of seconds. Now closely observe this. What are these? How do we use this shortcut hotkeys or cheat codes or cheat keys? Simply look at it. Okay, simply look at that. Here, these are the letters on your keyboard. These are the letters or numbers of your keyboard. Letters or numbers top of it. By using these numbers and letters on your keyboard, you can under which you have seen, right? This is 0 0. You can use it to 0 number on your keyboard. You can use it to generate a single bond. Here you can see all these single bonds. This is a primary single bond, secondary, on aromatic ring single bond. So if you press 0, then automatically single bonds will appear. Okay, if you press 1, then automatically here you can see the directions are a little bit different. Both are single bonds only, but different directions. That is the only difference. You will see that. I'll show you. 1 and 0 are meant for single bonds. This you remember it. Whenever you want to just type without using the mouse, without using the main toolbar, because in the previous example, when we were trying to just generate a single bond, what we were doing with the mouse, we are going to the main toolbar and we are pressing that single bond, and we are coming back again and we are trying to put that single bond in the places where we wanted to. But without using the keyboard, without using the mouse, without using the main toolbar, you can generate a single bond simply by using the letters, the numbers of 0 and 1 on keyboard. So this is something with the keyboard only you will be in a position to, once you excel in the sheet, that to generate any kind of bonds. Okay, just look at it now. Second, Okay, if you use this second number on your keyboard, then automatically you will generate this C double bond O. C double bond O. That means carbonyl group, you can generate it. Carbonyl group, you can generate it. 3RA. 3RA, that is benzene ring. Okay, that is benzene ring. Okay, let me show you first with these numbers. 0, 1 for single bonds, and 2 is meant for carbonyl group, and 3 is meant for benzene. Just like that, every other keys. These are meant for atoms. Atoms means, you know, let me show you that how it works. Okay. Okay, how it works, I'll show you. First of all, initially you should start with one single bond with the main toolbar. With the main toolbar. Okay, just to use only your mouse and main toolbar only once initially, and try to bring that particular single bond. Then after that, you try to see with keyboard only, I'm trying to operate it. With keyboard only, I'm trying to operate it. Here, you try to see that. What I'm trying to do is keyboard, I'm using arrows, up and down arrows, up and down arrows. Okay, up and down arrows. And there is a just for a second. So now what does that mean? Simply up and down arrows. That means, you know, the highlighter is moving one end to the middle of the bond, then after that to the other end. Just you can see, you know, that is middle of the bond, that is one end of the bond, that is another end of the bond. So that's how you can do it. So where you want that single bond, according to that, you can use up and down arrows. For example, I want at the top one single bond, here one single bond. What do I do? What do I do? It's very simple. I will just take my arrow to the top bond and I'll press 1. Press 1. Automatically another bond comes. Now again, I want another bond. Again press 1. Again press 1. Okay. So just look at it. How quickly I am able to do that. How quickly, wherever I want to do, I can move. Okay. So 1, 1, 1, 1. You know, with 1, I could be in a position to, you know, add single bonds. Okay, wherever I want to add single bonds, I can use keyboards only. I am not using any mouse or any main toolbar. Okay, so what is this 0? 0, it's very simple. If I press 1, just look at this. Here, I want to add one single bond with 0 and 1. Okay, if I press 1, it is going in this direction, right? If I press 1, where in this direction, left direction, it is just going. Okay, if I use 0, it is going on the right direction. So it is meant for different directions. That's it. It is meant for different directions. So what is that? 0 and 1 both are used to generate single bonds with the help of keyboard. How do we do that? Simply, if you press 1, then automatically it goes in one direction, and exactly in the opposite direction, 0 will make a single bond to appear. That's how we can just generate as many single bonds as possible. Okay, just look at it. Okay. Okay, this is very simple. Okay. Okay, this is how you can generate as many, just using these arrows. Okay, up arrow, down arrow, right arrow, left arrow, and you can move to any place you want. Okay, then there, if you want to use you know, this 0 or 1, 0 or 1. Okay, 0 or 1, 0 or 1, just like that. You know, you can use 0 and 1 to generate single bonds. As many single bonds that you want, you can generate. That's not a problem. So these are 0 and 1. When it comes to 2, what is that? Simply, you know, in place of 0 and 1, if you try to press 2, then automatically carbonyl group appears. In place of 2, carbonyl group appears. Okay. So again, you know, you can use this, you know, if you want here. Okay. Okay, you can use you know, up and down arrows, and you can select you know, carbonyl group at any point wherever you want. You know, you can generate carbonyl group. Okay, carbonyl group. Okay, now what did we see? That, you know, we want to add a benzene ring by pressing 3. You know, if you press 3, then automatically another benzene ring gets added. Okay, just look at that. Okay, so if you want to add, for example, benzene ring, press 3, then automatically benzene ring gets added up. Okay, this is how. simply don't, without using mouse and without using any toolbars, if you remember these cheat codes or cheat keys, and then automatically you can remember, you can make your whole platform to come up with different kinds of groups and bonds and everything. That's not going to be a big difference. This particular sheet of cheat code is just going to help you a lot. Okay, let me just delete this. Let me show you cheat code again. Okay, so this is what it is. So if you use four, let a number on keyboard, then automatically you'll get this stereochemical representation of thick edged bonds. Okay, five hashed bonds. Okay, 6 cyclohexane group. When it comes to 7, cyclopentane. When it comes to 8, this is double bond. So some people might be asking, how do I add in place of single bond, double bond? It's very simple. Simply use 8 number. Okay, this is secondary carbon. Carbons, single bond. If you want to add 9, this is triple bond. For a triple bond, you need to add letter of Z. Okay, these are as far as atoms are concerned. These for our atoms are concerned. If you want to add, that means you need to put your cursor or highlighter on one end of the bond. On one end of the bond. Let me show you that. So here, first you just take one single bond, then after that just look at it. Here, middle cylindrical highlighter is meant for bond. On when I'm moving onto one end, it is becoming circular. Okay, that means what, there you want to add anything, and whatever the numbers that I've told you, just those will help. So if you want to add 2, automatic, if I press 2 and you got a carbonyl group, let me go to the another end. Okay, let me show you. So when it is there on the middle, if I try to just type 2, okay, a bond will be created. Whereas here, when highlighter is there on the one end, if I press 2, a carbonyl group is coming. Okay, if I put it in the middle, the highlighter, with the help of arrows, if I just press 2, then a double bond is just coming. Okay, double bond is coming. That means there is a difference. If a highlighter is there on the ends of the bonds, the groups that get generated, they are different from when they are in the middle of the bond. That is something very important that you need to just care up. These are with arrows, you can move from one place to another place. Okay, this is how you can do it. Okay, let me show you with second number, and we can add this third number, benzene ring. Okay, then again let me add one single bond. Then after that, let me add 6. Okay, 6, we know that cyclohexane, and let me add another single bond. Then after that, that small z will bring a triple bond, another single bond. Let me add it, and to that, if you add 8, there will be a double bond. Okay, let me add 0. Okay, if you want to add, for example, secondary thing, sorry. Okay, 8. Okay, 9. If you add 9, automatically secondary carbon comes into the picture. Okay, then after that, again one single bond. Okay, 0. If you want to add it, you can add it. Then after that, again, if you want to add another benzene ring, you can add 3 number. Just like that, with the help of only keyboard, you can generate the molecules. That once you generate the molecule, then automatically you can generate with the help of control button, n number of times. Simply you can make copies of those molecules, and you can just write reactions quite easily. So that is something very important. And I want you to see, I want you to see the samples. This is now here you see atom hotkey. This is atom means end of the bond. Okay, here you can see bond hotkey. Bond hotkey means when the highlighter is there on the bond. If you type A, there is a fused benzene ring that appears. If you want a benzene ring, when highlighter is there on one of the ends of the bond, you need to type 3. But if you want to have a fused benzene ring, what you need to do? You have to put the bond highlighter. Then after that, you have to type A. Let me show you that. How does it look like? Okay, let me have one single bond initially. Okay, otherwise just okay, benzene ring. Okay, benzene ring. Now show that I am trying to move the highlighters throughout the molecule. Okay, throughout the molecule highlighters. Now if I put on the the highlighter on either end of the bond, means highlighter will be in the circles. Okay, circle. So then if you type 3, another benzene ring will come. Okay, another benzene ring will come. Now if I put the highlighter on the bond on the bond, not on the either end of the bond, but on the bond, middle of the bond. And if I try to type 3, then what is coming? Triple bond is coming, not fused ring. Okay. So when it is there on the bond, what you need to do is A. If you type A, okay, if you type A, another benzene ring gets added. Just look at it. As many number of benzene rings as you want, you can add it. Okay. So are you getting my point? If you put it on the bond and you type A, then automatically as many number of benzene rings you can add it. So otherwise manually, what do we do? If we want to add a fused rings, we will press this and we will press this like this and again press this like this, press this like this. Okay, this is how we do it. Okay, and manually doing all these things not needed. Simply put that highlighter on the bond, simply keep on typing. So yeah, just like that. It doesn't take much time for you to just generate these structures. Okay, now let me show you other bonds, because this is something very important. That's why I'm trying to just spend a little more time on it. Okay, so just have a look at this cyclopentadiene. This is Z. Here, if the highlighter is there on the either side of the bond, if you press Z, you will get triple bond. If it is there on the bond, if it's there on the middle of the bond, if you type Z, you will get this cyclopentadiene fused ring, cyclopentadiene. Okay, here if you type here, you can see that if on the bond, if a highlighter is there on the bond, if you type 2, you will get double bond. If you type 3, triple bond on the bond. Okay, then here cyclopropane ring, if you want V. Okay, cyclobutane ring, 4, 5, 6, 7, 8. These things you can remember very easily. Just look at it. 4 means cyclobutane. 5 means cyclopentane. 6 means cyclohexane, cycloheptane, cyclooctane, just like that. 9 and 0 are meant for chair conformers of cyclohexane. So it is very easy for you to remember these keys. It is very easy. Let me show you. Okay. So for example, the bond is highlighted. I am not using any of my mouse. Simply bond is highlighted. Just look at it. Highlighter. I am not trying to highlight the either end of the bond. I am trying to highlight the middle of the bond. After that, if you type A, you will get benzene ring. Okay. If you type 4, you will get cyclobutane. If you type 5, cyclopentane. Then 6, cyclohexane. Then 7, cycloheptane. 8, cyclooctane. Just like that. Okay. Now, if you want to move, just move all the way to here. Okay. So here, if you want to add, for example, okay, cyclohexane conformations, you can add it like this. 9. Okay. 9 or 0. Okay. 9 or 0. Okay. All these things. How much is it? It's not a big difference. See, once you draw different kinds of structures using this cheat sheet or hotkey sheets, then definitely you will register all these numbers or the codes in your mind. Whenever you want one bond, this is how I'll do it. This is how I'll do it. Without using these toolbars manually to click, selecting, and after that, pasting or borrowing all the way to canvas, and simply use the keyboard. Just with only keyboard, 90% of the structures you can write it. Whenever you want a little bit things, manually you can go and you can borrow them. That's not a problem at all. Okay, this is all about the hotkeys cheat, sheet. Hotkeys cheat sheet. I want you to see for a little moment of time. See, that's what I'm trying to tell you. In the first class, I have told you how to get the software. Second class, I have given you all the tools. First of all, you need to learn. You need to know how many different kinds of tools are there. Then after that, third class, I just started to create molecules, different kinds of molecules by taking different kinds of examples. Now, in the process of creating, I have tried to use manually all the tools that are present in the toolbars. Try to use manually. Okay, you can use cheat sheet, this hotkeys sheet to generate different kinds of bonds and different kinds of groups. Along with that, this is okay. Somebody might raise a question. So this is okay. If we want some other, like toolbars or some other tools, which are not there in this list, how can we get? Do we need to go manually and to borrow them here? No, you don't need to. There are, even after learning this cheat sheet, there is another set of shortcut formulas are there. With the help of keyboard only, you can generate or you can make them appear. You can make them disappear. Okay, there is a list of shortcut formulas are there, which I'm going to teach to you on the last day. So that will be the end of the whole program by tomorrow. after just telling you all these shortcut formulas with the help of keyboard. So if you keep this hotkeys cheat sheet in your hand, along with that some other keyboards, so some other shortcut keys, in your hand, don't try to mug it up. Okay, simply try to practice it, then automatically you'll remember it. Once you have all these things, these things in your mind, I'm telling you, this is going to fetch you, in future, when you go to higher studies like MSc, research and jobs in chemical industries, there you will not feel like out of the place. In fact, you will try to relate this software with other softwares that are present in the market. So automatically you will try to relate yourself that in which way other softwares are better. Already I'd be able to draw these kinds of structures on ChemDraw. Is the other software is much better than this or not? So that's how the moment you enter into, you'll start to learn. That means there will be a little bit of edge of you or the other people who are working over there. So that is something that it is going to create at this program. This program is going to enable you, like empower you to become a better chemist student or a chemist in future. So somebody is just asking, sir, can we get a job based on this? Okay, it's a job means just a thing. I'll tell you one. Of course, it's not a great example, but might be a stupid example also. I'll tell you two examples. One example is myself. See, when I was in BSc, my father just asked me to go and learn typing. See, learn typing. These days also nobody learn typing. Typing their things, this is just a old dated thing. Okay, but I suggest everybody should learn typing, at least for 1 month or 2 months. Why? Because I have learned typing. Now I am in a position to type even a big programs. You see, there are so many good people are there, great people and intelligent people, because they don't know how to type. When they are going to type lengthy programs, they will type letter by letter. See, because I've learned typing, that made me an edge over others when it comes to executing, typing different programs and executing it. See, that will give a lot of confidence to me. Whenever a lot of amount of work that is to be done on the computer, I will never hesitate. I can write even 300 pages of a report also just in a matter of 1 or 2 hours. That means what? It will empower you. It will empower you. That is something very important. Another example I'll tell you. There is a person, he just finished his PhD and all of that. Then after that, he was very good at this ChemDraw. He made a couple of ChemDraw videos and he kept it on YouTube. He tried to explain all these techniques and tools and all of that. Do you know this Pekin Elma company recruited that guy? He did not even imagine that he worked in one area. He is trying for a job in that area. Meanwhile, he tried to do a couple of videos on ChemDraw because he was very much interested in it. He kept it on YouTube, and the company has saw him and recruited him that by paying a lot of amount of money as a marketing head. So he did not even expect that. So sometimes what happens, straightforward, if you learn this and you are going to get this job, such kind of things, will not might not be there on place. The point is, you just learn as many things as possible in your student life. Okay, you try to learn as many skills as you can. Okay, equip yourself. Okay, be confident. Then you just go to the market. Then automatically you'll get the opportunities, of different kinds. Definitely, you will be preferred over other, people. That's going to happen. That is what the take-home message of today. And tomorrow, the rest of the shortcut keys along with that, and we'll be going to have an examination, a small examination. Don't get scared of. Okay, just I'll ask you a few questions, like 5, probably maybe maximum 10. Okay, based on the discussions that we had it in the last 5 days, including the 5th day. Then after that, we are going to just create a feedback form tomorrow, and we are going to send it. And I just want you to just attend tomorrow's class compulsorily, and try to just attempt the examinations and feedback. Let me quickly go through the doubts that are raised in the chat box, so that I'll end up this program now. So configuration option, either R and S. Yes, sir. It does not have a configuration option either R, S, or R and S. R and S configuration they have. Actually, this is very simple. If you try to rotate the molecule, if you try to flip the molecule, otherwise you take the molecule for which there is a S configuration, you take exactly flip that molecule, then automatically you'll get the R configuration. So you can generate S and R very easily. That is not a problem. Sir, will you please provide us the notes? Yeah, we will provide reading material and all of that. In your those people who are going to write the examinations after attending these classes and feedback, they are going to get all of that. So I mean, which explains I mean, which explains the configuration. Configuration means which explains. I did not get the question properly. How to add numbers? I have already told you that you should go to object and object settings. There you can add the numbers. Sir, from structure toolbar, we can also do directly take a proton NMR spectral data and no, sir. Yeah, yes. From structure toolbar only, we will just get all this data of that particular structure. Good afternoon. Sir, should we type a common name or a UPAC name to convert? Both the names work. Both the names work because the database is just filled with all the common names and most of IUPAC names. So both the things work. Sir, is it applicable for common names? Yes, it is applicable for common names. You want me to show? I'll show you quickly. I'll show you quickly. For example, I told you now, acetone is not a IUPAC name, right? Okay, acetone is not an IUPAC name. So let me just type acetone or acetic acid. Okay, acetic acid name is what? Ethanoic acid. Okay, acetic. Okay, acetic acid. I typed. I got it. Okay, let me just show you one small thing. If I select this and if I get the name, okay, I'll get this one also. Sometimes what happens? IUPAC name. If you want to, for example, let me show you. Okay, acetic acid, ethanoic acid, ethanoic. Okay, both the structures are same. Just look at it. This is ethanoic acid also. It gave the same structure. Acetic acid also. It gave the same structure. So you get both. Okay. Common name is over. Sorry. What are the number? Common names. So how to open the shortcut keys? Can you tell me? That's simple. File, go to file and open samples. Under open samples, you have this enhanced hotkeys cheat sheet. That is what the thing. Open file, open samples. Then after that, enhanced hotkeys cheat sheet. Okay. In mobile ChemDraw, no. Mobile ChemDraw, no. First of all, ChemDraw is not there on the mobile. Sir, I can only find magic hotkeys cheat sheet, but not enhanced. See, it depends on the version. People have given the name of previously magic and our 19th version, So at the end of the day, that is hotkeys. Hotkeys are there, just you borrow them. Is there any software does this hotkey sheet same? No. This is a very unique for this. And I'll tell you one more beautiful thing. Though that cheat key sometimes you might not like letters. For example, for A you don't want benzene ring. For A you don't want benzene ring. If you want to put for A another thing also, you can change it. That kind of you can customize the cheat sheets also in ChemDraw. That's the most beautiful feature of it. See, according to my convenience, the way I like it, the letters for this letter I want some structure. For this letter I want another structure. You can do that. You can customize that. That's the most beautiful feature that I like. I liked it in ChemDraw. Is every sir? What if the reactions are like A plus B? Yeah, you can just write simply two structures. Then after that you can carry on. What's the problem? Simple. See, as long as you have given an option to make copies with the help of control, what are the basic things? First you create it. Basic things only you create it. I told you manually also you don't need to do it while you are going to create the structures. You can borrow directly from name to structure. Otherwise, you can use cheat sheet code or this sheet, and you can another shortcut formulas also I'm going to teach to you. With all these is you can borrow the basic structures. Once you borrow that, then after that use control and arrow buttons. Automatically you can generate n number of structures. Which type of questions are going to be asked tomorrow? Shall we practice this in ChemDraw? ChemDraw is not a replacement for that. Just I gave you an option of two things for those people who are having cell phones. ChemDraw app and a direct ChemDraw website is also there that I have already shown you on the first day. How can we get IUPAC names? It's very simple. You just simply select it and press structure to name. You will get it. What are the bonds in multiple bonds which are like SD or SA? Acha, this is not I think they are asking any type of bond. If you want to just these are any type of bonds. Sometimes if we are not being specific, we will make it generalized. We'll make generalized so that the structure appears different kinds of. Sometimes that happens. If you don't want to specify the bond, you can put it. When converting structure to name can be both. No. Any one name it's an automatically generated. It will give any one name. Only magic hand keys are found. Only magic hand keys are found. See, use that. The name could be anything. As long as these are shortcut names, because version to version they are changing. For example, I'm using 18.2 version right now. because I have 18.2 version, I'm using that. In 19 trial version that I have suggested to you. Some people have told me that 12.0 version is there. Some people have told me the 16 point version is there. But one way or the other, the concept is same, that hotkeys. They are using cheat keys, means that is just generally they are trying to use. Can we find structure by using proton NMR? Proton NMR structure means, first, if you have proton NMR based on that the structure, in one way they have given, the other way they did not give. The other way did not give, because this particular software is not meant for drawing, spectra. Then after that, according to that doing, it's not that. How to get 3D structures? Actually, that is something that I wanted to cover it, and just briefly I have shown you on that day. It's very simple. Once you create the structure, select it and get to 3D model, then double click, automatically a 3D window will be opened. So that is one thing. Because time is just not there, I'm not going to go in. As you told, we need to sure. On social media that I'm learning ChemDraw basics, and one of them asked me how to use and install the ChemDraw and explain them about it. Thank you, sir. As you told, we need to learn the skills. Okay. So tomorrow, which topic you are going to tell? Okay. Probably based on that, whether she wants to come or not. It's all about shortcuts. And one important thing, if there is a time, I just wanted to cover that. That is a catalytic cycle. How to draw that catalytic cycle? That is also very important. People can use that thing for a project works. Good evening, sir. Okay, we can practice ChemDraw only in systems. There were no other possibility. Yes, as of now, there is only Windows version and Mac version. Unfortunately, there is no Android version is present. Okay, that's all for now. So, Shukla sir. Shukla sir. Sir, am I audible? Sir, unmute yourself, sir.
Okay, unmute. Principal madam is there in the meeting. Kindly unmute Vijayalakshmi madam also.
Okay.
Principal madam, please speak up.
He's so immersed teaching that he never sees even principal coming. Huh?
I have to get stick to the time.
He's professional, ma'am. He's professional.
Truly professional. Yeah.
Yes.
I agree. Good afternoon, all the participants and dear students. Tomorrow will be the last day of this session, and
Instruction.
last day for the instruction, and maybe some material also will be given to you, and you people need to keep practicing. There will be also a test which you will have to write. Don't worry, even if you are failing in the test, we'll give you a certificate. But here the learning is more important, and learning the skills are important. It is not the passing or failing in the test that is important. So as learned people, we believe in that ideology, and keep practicing, and stay connected to this college, and enrich your knowledge. That is what we wanted to tell you all. All in all, I must congratulate once again the chemistry department for taking this initiative, and many more things should really be taken after this. Let this not be the dead end of chemistry department. So many more feathers on your cap should come. Okay. I think we will enough.
Shukla sir, unmute yourself. Acha.
Well, let us ask even Satyanarayana sir what he has to say. Satyanarayana sir, చెప్పండి ఎలా ఉంది? How did you find this course? Was it interesting? Unmute చేయండి.
Unmute.
Yeah.
Yes, sir. Yes.
Madam, it's wonderful, madam. It's a wonderful opportunity to join in this program. I too elevated a lot because I learned it long back and I forgotten, and I am not able to draw the structure actually for the recent classes purpose. But when I have listening these classes, actually which were for the purpose of the student, but we will get benefited a lot. For this, I thank you a lot for giving the opportunity, and also I thank you the Department of Chemistry and rest of the faculty, and especially Anil sir. Yes. Thank you, madam.
Thank you, sir.
Thank you, sir. It was wonderful knowing that always as teachers, we need to learn, unlearn, relearn, and always keep learning. That's it.
Thank you,
Okay, my dear friends, I will tell one thing. As Busi said, for drawing a carb, I was supposed to prepare a carbohydrate PowerPoint presentation. I took 1 month to draw all these structures. So I was not having awareness. I did my MS in 1986. So there is a generation gap between Busi Anil sir and me. What I can find is I have wasted a lot of time. If I would have known this ChemDraw, It was a matter of 1 hour or 2 hours.
You
So
should
really,
have
I thank
connected. You should have
in
connected to
advance.
Bussy. Yeah.
Busi.
Mm.
Yes, ma'am. So you are lucky enough to learn these things, and hope you are enjoying the sessions. Tomorrow at 3 o'clock sharp, we will meet again, and try to come early so that we cannot waste 5 to 6 minutes of time. Try to join early. And I appreciate Busi for his efforts, and I thank Principal Madam for a note and Sadanand sir for giving his suggestions and views. Thank you, one and all. Have a nice time. Be safe. Take care of you. Goodbye.
Okay.
Thank you, madam. Thank you.